In an increasingly polarized world, moments of bipartisanship and cooperation can be rare to come by, especially with regard to environmental policy. However, there is one moment in world history that reminds us it is possible for us to come together for the betterment of humanity. This moment was the Montreal Protocol, an international agreement that is considered the most successful environmental treaty to date. On September 15, 1987, countries who signed the Montreal Protocol pledged to phase out the use of chlorofluorocarbons, more commonly known as the chemicals that cause the hole in the ozone layer. To date, 197 countries have signed the agreement, and the ozone hole is well on its way to recovery. To understand what mobilized the need for such a huge international agreement, let's start at the very beginning. In the 1920s, refrigeration units, aerosols, and air conditioning units contained chemicals like sulfur dioxide and methylformate. These substances were highly corrosive and flammable, and came with nasty side effects if leaked. An alternative was needed. In 1928, the invention of chlorofluorocarbons, also known as CFCs, became that alternative. Invented by Thomas Midgley, these simple chemicals were non-toxic and non-combustible. They were widely adopted as a safer alternative. By 1930, the industry quickly moved to mass production. Decades passed. In the early 1970s, scientist James Lovelock noticed that the air of his small town in England would fill with a thick mystery smog every summer. Dr. Lovelock had invented a scientific instrument that could measure quantities of chemicals in the air. He put it to use to determine where the mystery smog was coming from. He hypothesized that the smog was coming from more developed Europe. CFCs were the perfect chemical to measure because they were man-made and had no natural counterpart, so if the smog was coming from Europe, it was sure to contain them. Lovelock's studies showed CFCs in the wind coming from Europe, but they were also coming from the empty Atlantic. Lovelock brought his studies to Antarctica, and to his surprise, he found CFCs in every air sample. He published his findings to the scientific journal Nature, but concluded that these compounds represented no conceivable hazard. Fortunately, two scientists at the University of California, Irvine, were interested in picking up where Lovelock left off. F. Sherwin Rowland enlisted postgraduate student Mario Molina. Dr. Molina found that CFCs were so unreactive that they could stay in Earth's atmosphere for years. At a high altitude, the CFCs would be broken apart by the sun, releasing chlorine, which would wreak havoc on the Earth's balanced and fragile upper layers. The importance of our atmosphere, specifically ozone, cannot be overstated. Ozone is important to all life on Earth as it blocks ultraviolet radiation coming from the sun. When chlorine is released into the upper atmosphere, it destroys ozone at catastrophic rates. When CFCs were at the height of their use, a giant hole in the ozone layer started to appear, right over Antarctica. This was happening at such a rate that the ozone hole covered 21.2 million square kilometers. The media began reporting on the ozone hole, and people got scared. A public turning point was in 1975, when a special episode of America's most watched show, All in the Family, aired, in which the two main characters, Gloria and Michael, fought over the use of hairspray.
What about spray cans?
What?
Yeah. Here, right here. This is a killer.
Oh, so now my hairspray is a killer.
Yeah, your hairspray, my deodorant, all spray cans. I read that there are gases inside these cans, Gloria, that shoot up into the air and can destroy the ozone.
Yet, these boycotts did not deter the chemical companies. Some ignored the complaints, whereas others argued against them with propaganda. For example, some claimed that scientists had ulterior motives, such as destroying American economy. Despite pressures from congressmen, companies stated that data needed to be clear. Only then would they take action to halt the production of the chemicals. Debate in the U.S. government continued as leaders of the Environmental Protection Agency noted that a U.S. solution alone would be insufficient in creating necessary support and making a substantial change. A global ban was needed, which would require scientists from around the world to share data that supported similar findings. Although international support grew, no action was taken against CFCs. Scientists needed to provide data that showed causation between the two substances. Science was an absolute must. Teams of scientists were sent to Antarctica and Chile to measure the damage and figure out why the ozone hole was happening over Antarctica, but not the entire Arctic. They discovered that the stratospheric clouds over Antarctica housed CFCs until the spring, when sunlight tore apart the atoms, releasing chlorine and destroying the ozone layer at terrifying rates. The data was clear now, and it supported their claims. Yet, someone to lead global action was still needed, as debates and disagreements continued. Interior Secretary Donald P. Hodel proposed doing nothing about CFCs, and instead proposed a plan called the Personal Protection Plan, which meant humans should wear sunscreen and a hat to counteract the negative effects of CFCs. Political propaganda boasted on Hodel's ignorance, and many high-ranking U.S. officials took heat on both sides of the argument. President Reagan jumped to the EPA's side and discouraged Hodel. The United States was not alone in these problems, but was quick to blame other countries for the lack of action. Debate continued, as agreement was scarce and understanding of the issue was still not widespread. President Reagan's history of lobbying for pro-industry suggested that he would not take the side of banning these chemicals. Yet he did! Soon he took a spot as leader, and action was finally taken. In September of 1987, Lee Thomas from the EPA was sent to Montreal to negotiate for a global ban. Written agreement, which had been stalled, finally opened as the US and Soviet Union came to agreement on terms. Finally, on September 16th of 1987, what became known as the Montreal Protocol was signed.
It's being called an unprecedented display of international cooperation to protect the world's environment. The Montreal Protocol, signed today, aims at stopping the deterioration of the ozone layer in the atmosphere. That's the layer which shields us from damaging ultraviolet radiation from the sun. But there's a lot of work ahead before the commitments become a reality, as our science specialist Yves Sabry reports.
Congo.
In the end, only 24 of the 49 eligible countries signed.
United States.
But most of the others intend to soon. And if enough of them ratify the protocol, it is probably not too dramatic to say they may have saved the world.
The Montreal Protocol improves the odds in the risky game the world has been playing with its own future.
Although the Montreal Protocol was considered successful as the first global environmental treaty, now the main challenge shifted on how to accomplish the goals of the treaty and reducing the use of CFCs. Scientists released the final data, showing that when ozone dropped, chlorine levels heightened. The ozone problem was in fact man-made, thus putting chemical companies back into the spotlight. Mac McFarland was the chief scientist at DuPont Chemical Co., one of the companies that had promised to shut down its CFC production if the evidence was prominent. He calculated that a complete phase-out would be needed to decrease atmospheric concentrations. His bosses agreed, and they committed to action, but they did not provide a timeline. So many products that humans relied on used the chemicals, and safe alternatives were needed. And the challenges didn't end there. Developing nations and nations in extreme debt could not afford the CFC-free alternatives. Almost no nation was willing to step forward to help. Almost. A solution came from a surprising place: Margaret Thatcher, the Prime Minister of Britain. Although Thatcher was not an advocate of industry regulation, something was different in this instance. She had been trained as a chemist, so she brought perspectives that other leaders did not regarding the critical need for global intervention. She stood among the world leaders and encouraged them to provide funds to support the meeting goals, and with the new support, developing nations joined the protocol.
Every country will be affected, and no one can opt out. Each country has to contribute, and those countries who are industrialized must contribute more to help those who are not. It is life itself, incomparably precious, that distinguishes us from the other planets. It is life itself that we must battle to preserve.
To date, 197 countries have signed the agreement. With the joint and unified effort of science and politics, the recovery of the ozone has continued successfully, and is expected to be fully healed by the year 2030. Overall, the Montreal Protocol is considered to be a tremendous success, as a globally signed treaty centered on environment and pollution. The work to create the treaty demonstrated global commitment to breaking barriers both across and within science and politics. However, the Montreal Protocol must not be the end, as we face many serious challenges in environmental issues today. We must use the lessons in collaboration and leadership from the Montreal Protocol to break the barriers that currently separate us.